So you can have a backup whereby it will be replicated only within data center. You can have a backup whereby, yes, we have a copy in data centers. You also have copies within the region. Okay. But any configuration you are doing that is giving you opportunity to have your data virtually everywhere is more money. So, but people are always looking for a way to reduce cost. All right. So another thing I want us to also look at is our data store. Look at our data store. So these are the type of data we are going to be talking about. We have table, Azure keys, file shares, and containers. So your container is like your normal folder. It's like a normal folder. So inside of your folder, you can create a folder and then you put files there. Okay? There's nothing. So look at it. Inside this folder called output stream data, there's a file called 2022 there. Then inside 2022.
No. Is it file you upload is it folder you upload, or you can upload file?
You can upload, look at it, you can upload file, you can upload folder.
Or you can actually upload folder straight?
Yes, you can upload folder straight. You can upload folder.
Okay, that's fine.
You can upload folder. So when you're there's what you call ingress and egress. When you're moving data into Azure, they don't charge you. You upload a lot of stuff on Azure, just like we have this part. Let's say this particular file now. Okay. So there's only one file here. This file now. But if I'm downloading this file, that is, I'm taking it away from Azure. I'm downloading it. It will charge me for egress. Okay, that's another thing you need to know about. So that's a container for you. So basically, your container would just store up blob. Remember your blob, your very large object. And then we move to file share. So one thing that your file share does is that it is easier for you to map. You know, you can go to your laptop and then create a file share from there. And then you map everything inside your laptop. You put it there, and then you move it to the cloud. So now anytime you don't need to sign in to Azure to access your files. You don't need to, you understand? So which means there's a relationship between a particular promises and what the person is getting. Okay. Another one is queue. Then another one is table. So this is the Azure table. So let's see if we can create a table. Okay, so this table, now can you see the beauty? This table has a unique URL. That's a unique URL. So you can do an access policy that, oh, I only want people with this ID to enter into this table, or I only want so person That is another thing. So let me go back to our slide. As you can see, these are the different types: the container, the file share, the table. Why I went to Azure Portal is that you know where to find them, so that when you create a storage, because anything you put inside that storage can be seen anywhere. So there are still some other configurations. But for your level, just know where they are, because those are the things they will ask in your exam. Where they are.
Like what?
All this is what I just showed you.
Okay.
What I just showed you. You will ask questions around container, around file share, around key, around table. Okay. So you will ask questions. You will ask questions around them. Okay, so let me continue with. All right. So now let's explore CosmosDB. Now, one of the reasons why people love CosmosDB is that on Azure now, it's scalable. Okay. I don't know if you know what they mean by scalability. Can you tell us that?
Does not have to it can like the compute kind of, is it? Or the
That's what I want to understand if you understand the word scalability.
It can increase and decrease performance or something.
Okay, good. Can increase and decrease resources based on what you want. Because you want performance, so you want something that will keep performing for you. Okay, so then the performance is good, is known worldwide. There is always available, deploy it. Then it has the programming model. Of course, we will blend all of this over. So for Azure CosmosDB, so Azure CosmosDB multi-master replication model along with Microsoft Performance Commitment. Data engineer can implement a data architecture to support web and mobile application and achieve less than 10 response time. So Azure CosmosDB is built for this. So this particular place, I saw it in one of the questions.
What's that?
I will like it. So they were asking about CosmosDB, what it does. So it's a multi-master replication model. So along with Microsoft Performance Commitment. So what are they trying to say is that CosmosDB doesn't belong to Microsoft. But Microsoft enjoy the rate at which this DB performs. Do you understand? That's why they are referring to it as a master replication model along with performance, then commitment. Data engineers can implement a data architecture to support web. So now that data architecture was what you were asking for the other time. That can they do it and all of that? So, You get. So this point, please, it's very, very important. Okay, so this data engineer can implement a data architecture to support web, to support mobile application, and achieve less than 10 seconds no time. Anyway. So another area is gaming. Of course, you might not really be into games. The database here is a crucial component of gaming application. The modern games perform graphical processing on mobile/console client, but rely on the cloud to deliver customized and personalized content like images. Okay? So you can also make use of the IT scenarios. Hundreds of thousands of devices have been designed and sold to generate sensor data, known as Internet of Things device. Okay, so most of these devices they are working together, you know, working together in making sure that they deliver onto us that promise. Okay? So hundreds of thousands of devices have been designed to generate sensor data from an Internet of Things. Okay, so I'm not sure if one of the things that I did recently was this IoT stuff, IoT AI stuff. Okay, let me try and show you. How do I put it? Okay, so Raspberry Pi. Raspberry. Okay, so start Raspberry Pi. Okay, sir, can you see what's up there? So it is called Raspberry Pi Azure IT, Azure Housing Online. So which means that to do IoT is very expensive, but Azure can at the same time try and minimize some of these things. Okay, so it's like a simulator. It's like an hardware device. So instead of hardware device, they put some certain things there, and then there's a code that will join, it's called streaming data. So this data will drop every second, every second, every second. So what type of data is that? So it's really, really going to help. So when it comes to that training, I'm just showing you this, not because it's part of your curriculum. No, it's not. Just for it. Okay. So now you already get yourself familiar with this. So hundreds of thousands of devices have been designed and sold to generate sensors, data known as Internet of Things. Okay, so using technology like Azure IoT or data engineers can easily design a data solution architecture that captures real data time. So I want you to underline that. So whatever it is that these guys are doing, they were able to capture real data time. So as it is happening,
Yeah.
do you understand? So then you now go and analyze those data, and then so you can now say, oh, you understand what I mean? So
Yes.
just go and analyze it. So I wanted to show you on my profile because I ran an IoT recently, and I think that is what is inside the what's it called, that storage account. So that you see the way you see how it look like. Okay.
Yeah.
So look at this storage account. I named it Stream Analytics IoT. Can you see?
Okay.
Stream Analytics. Whatever the reason why I was named this is because I know I'm of course I'm working on analytics, and the analytics is talking about stream, like a stream data. So that means data will be collected every second. So now when you come into hey, which other one the other time? Okay, I think table, not table. Okay, you come inside your container, yes. So from your container, you can create a container like your folder. I told you your container is like a folder. So because look at the day I created it, 28th of February, around this time. I was working on a, what we call streaming data. Okay. So it's going to be part of your next level when I'm training you. Because it helps you to do what we call of course, it just helps you. Don't worry, when the time comes, you will do it. But I just want you to know that this is an output of a stream data. Okay. So an output of streaming data, right? So inside, because it was automatically generated, you just pick the year, the date, and all of that. So if I open the year now, my streaming data, so it was computer that generated it to that thing that I showed you.
Mm-hmm.
Yes.
You
So
set parameter of information you want it to get.
sir?
You set like a parameter of the kind of information you want it to get.
Yes, the parameter is already here. Parameters are already, where is this? I don't like it. Sorry, trying to look. Where is this thing? What machine is in that? Where's the Raspberry Pi? Close it.
But you can still talk on through it now. She been my DB.
Yes, as you know, I'm of FE. Just want to show you so. Okay. Okay, so basically this was the data generated. So you can see. So look at this data now. I click on it. And click on this data. So this data has its own URL. So which means that anybody in the world can connect to this data. If I opened that, okay, this data should be public access. You know what I mean?
Mm-hmm.
So if I say private, so only people inside Azure can have access to this data. So it's the stream data from IoT. So we are supposed to analyze the data, blah, blah. So the day I generated data, month of March, okay. So type of block, see, block, bulk. Then look at the size, 8.9. The file is very small. Okay. So then I explained the access here to you that is fairly hot. Okay. So what is there? Okay. So here now you can see the overview of the file, the version of the file, the snapshot of the file, the generate path. So you can also edit. So in your edit, that's where you see how those data are doing well. So here you can see what sort of data we even collect in Jari. So it means that number one, you are collecting message ID. Then device ID. Then temperature, humidity. Okay, so the message ID. These are the message. Okay. Then you look at device ID. You know, in an organization, like I said, in an organization, they want to add you to your director, to their director. Then it's always a good thing to be added to, because which means you can follow things on ground. So now the name of this device is web client. Okay, so there's temperature, humidity. Okay, event processing time. Okay, so basically this is how this will look like. This is how we look at. So when I try to go to Excel now discover that I discovered that there is so much new.
So much what?
Can you hear me?
So much what? I can hear you.
Okay, like the one I work with at work. So the data has, I copied it inside Notepad. So to transform it into Excel so that it can give me something like this. In fact, the column in Excel could not carry it. The column that runs it to 1.1 million lines cannot carry it. So to analyze, yes, so imagine Excel has
Column or rows?
I mean rows rather. Rows. So to analyze it,
1.1 million. Which Excel is that? There's one that is over 1.1 million now.
That's what I'm saying.
Excel, there are two Excel. Which Excel is over 1 million, sir?
The normal Excel, Office 365 Excel.
How many rows, I mean columns, rows does he have?
The data I was talking about.
No, the Office 365 Excel, what's the maximum row?
I think it should be like 1.1. I don't know the value, but it couldn't control that log. I was, because I was trying to transfer the logs from normal text file to a CSV file. Yeah, so to a CSV file, so I can see. But I was looking for some incidents. There's a machine that something happened to. I was looking for some, and then reading those logs, it takes time, it takes days. So, but it's better if you find a way to query those logs. You know, okay, if I query this log, I know the integrity of. So that's why I was just trying to show you that data, the kind of data. Only if I preview now, you will see the way it look like. Message ID, device ID, temperature, humidity, and you know, this should be the different tables now. Table where cool stuff. So now, but it's better left. You just press it. Okay, so this is how it is. So work and download this file. Then put it like there. Start analyze it based on what you want. You know. That's so okay. That was it because I was also working on it. Okay, so let's go to the slide. Okay, so we are done with IoT, so we can now see what it can do. So explore provisioning and deploying non-relational database. So what we need to experience this. SQL, VMs, so you must learn also to find a way to deploy. Okay, so the lesson here is that provide provision of non-relational data. Configure non-relational data services. Explore basic connectivities and data security components. Okay? So after this, we just do after this slide, we just do some practical so that we can see how the whole thing is being run. Okay, create account. So now we can do a CosmosDB. Okay, create Azure CosmosDB account. But one thing about CosmosDB is that it's also a platform as a service, which means it's the service. Are not a contract. So now, so let's just go straight to provisioning a CosmosDB, just like the way we did for SQL Server. This is how we able to. Okay, just a moment. Okay. Okay. So let's deploy CosmosDB. So we go to global search. CosmosDB. Well, it's kind of hanging. Okay, so you can see there are two types. Azure CosmosDB, then Azure CosmosDB API for MongoDB. So those are two different types of operating systems. SharePoint. That's the one that says. So Azure CosmosDB API. So let's just deploy.
Wait. Go back to that. No, the way it was before. Yeah, now see, I'm seeing services and marketplace. Service, the marketplace.
I understand. You want me to explain?
Yes, please.
All right. Azure run what we call a marketplace. So virtually every organizations are now asking questions about that marketplace. So there are hundreds of Azure resources that one can use as a new guy. So now, but I'm used to a particular resource or a particular way of thinking or a particular way of doing things. Azure cannot have everything, Microsoft cannot have everything. But they are creating a platform where people can use what they got. I mean, what they have to use what they have to get what you have, what you need. So they put a place called marketplace together, and then they put all these software there. So even up to their own self, when they're looking for someone, make sure that they are going through that process. Okay? So thereby, the bet of Azure marketplace. So now just type and it will take you to the marketplace. So I've explained this area to you. There was a time like that I was taking this thing one after explaining it. So this is your marketplace. So there are third-party applications that Microsoft can trust, but they are not their own. So all they can do is to give these guys some certain level of some certain level of identity and nice you understand. So here is a marketplace, just like your Facebook marketplace, Instagram. So those marketplace. So where you put things there, and before you know it, people are always responding.
Okay.
So here now, you can deploy your CosmosDB here. Get. So virtually everything is there. As you can see, just click on Azure CosmosDB. No matter query, okay, John, do you want? You understand? We're looking at this one, the CosmosDB API for MongoDB. So then this is what we want, Azure CosmosDB. So globally distributed multi-mode database service. Okay. So from here now, Okay. They say CosmosDB is fully managed. So it's already one like fully managed, globally distributed, horizontally, and you understand? Globally distributed, horizontally scalable in storage and so on. Multi-modular based backup for 10 SME. So you can just create. Let's create it. Let's see how Azure Cosmos okay, which API best suits your workload and well, CosmosDB is a fully managed no SQL data service. So from here now we can deploy core SQL recommendation, core so Cassandra, Notable, Gremlin. So you can pick anyone. Just pick anything.
Okay.
Okay. Of course, you are familiar to this visual interface. And this is again. So, sir, I want us to go for like 5 minutes or 10 minutes. Please, sir.
All right, no problem.
Hello, sir.
Yes, hello, I'm here.
Okay, okay, okay. I wasn't there to go for that. Yeah.
Okay, okay.
Yeah. So now we are trying to create a CosmosDB account. Okay. So now look at what they said. It said create CosmosDB account that has what? That has a core SQL. So
Because
this one,
it can take more data now.
that is it. That is why this CosmosDB is powerful. It's powerful. Did you read at the beginning? Did you read what they said? Look at what they said.
Yes.
They said it's a full Microsoft.
Yeah.
What I mean by joke, you can't joke around with a service like this by saying we deployed it and we left it there. You know what I mean? No, I need to let you understand. So when we want to learn, we know that we really want to learn this, so we just leave it for that moment of time that I learn, and then why? Because it's fully managed. Now globally distributed. So that's the word. Globally distributed. It means that once you create to that particular resource, that's Cosmos database, then that's not only what what Microsoft has done in the back, you know, what I mean by in the back, when you say fully managed and the colonial accessible server, all those things. Now, what they have done in the back is this is let me show you the diagram so that you understand. So I'm trying to just okay. So Okay, so let just. I was trying to look for the world map where they have their different data center. So what that is saying is that they are globally distributed means that Azure has different data centers in different cities all across the world, and they have about more than close to. Okay, I don't want to give you just. Okay. Okay, so the idea of what I'm trying to say by global distributed is that they are Azure Microsoft can decide to pick a copy of your data and put it in any of the global, just put it anywhere. And then they will now create an API, the application programming interface, to begin to talk between those CosmosDB. You understand? So, which means number one, your data is virtually available globally. So it's a bit expensive. You understand? So the person data is globally acceptable. So why? Because if you're in China and you need to query something, you don't need to wait for our timeline to lag in Africa, or especially Africa that does not have fun. So that is where we have those issues, stemming from. So CosmosDB is a fully managed, global distributed, horizontally scalable in storage and throughput. Okay, horizontal storage. So that means you can increase the RAM size, you can increase the storage, you can increase the RAM. You can increase those stuff. Yeah. So I've explained what they mean by horizontal scalable in storage and throughput. So multimodal database service backed up by comprehensive SLAs. So Azure DB was built from the ground up, global distribution, blah blah. So there's a whole lot, There's a whole lot. There's a whole lot. But the few I want you to understand, that's why those ones are. So now we are trying to create a Cosmos DB. So he's saying Azure Cosmos DB is fully managed, no SQL server for building scalable high performance application. Okay, so to start, select the API to create a new account. The API selection may not be changed after. Okay. So to start with the API to create a new account, the API selection cannot be changed after account creation. So, so there are three types. We have SQL, core SQL recommended, Azure CosmosDB for MongoDB, then Cassandra, fully managed Cassandra database for apps written for Apache, Cassandra. Remember, if you have existing Cassandra workload that plan to migrate to Azure CosmosDB. So Azure CosmosDB API from MongoDB. So for me, you just pick one. You can go with create. So we are trying to create a CosmosDB. So we can give it a name. Small. Okay, this was
There's a problem with that name.
which one?
The resource group.
Yeah, it is the one I've been using.
Why is it not highlighting well?
No, that's the account name.
Okay, continue anyway. Because the color or somehow, that's what I was wondering whether it's
Yeah, it's kind of so.
okay.
So you say the name cannot contain the one. Okay. So that's the account name. Then account location is capacity mode, provision, top. Okay. Azure CosmosDB retail, you get up to and storage for free. Your account either free tier or okay, good. All right. All right. So apply free trial discount, apply, limit total account or approve. So let's go to global distribution. You know, like I said, disabled. So multi-region rights means that they can copy their data and put in different regions. Okay. So geo redundancy means that they can go in any of the region and say, oh, okay, there's this, and just say your geo redundancy means okay, it's global, it's beyond one region that you are. Okay, so you want that data to go beyond that region that for example, if you're in this region, you want it to go beyond the Canada shore, you want it maybe somewhere in Africa or somewhere in Asia. So you configure that. All right. So for networking, this is correct. Okay, backup policy, periodic backup, copy of data. Okay, fusion and custom managed key. Okay, okay. So tags and names. Okay, now these are tags, but you can see that they use table here. Keys and value. Give and Abi. I said these are tags. This is where you render your tags. You can say okay, training. Then put the name of VM. You understand? So
Hold on. Tags are named value pairs that enable you to categorize resources and view. Okay.
so all resources, of course, bring out tag. Okay, so what I was just trying to point out here is that the key slash value relationship here, which was what we just finished watching on both sides. Do you understand? So one way or the other, your tags too looks like a thing. You know? So you review and create. Okay, so we are trying to validate if you can create a CosmosDB. Okay, validation successful. Destination period.
We are not creating.
No, we are. We personally create it. I'm creating it now. So it's going to download. So the deployment is in progress. Let's just wait for it. All right, deployment is still in progress. So sorry, this deployment is taking some time, please.
No problem.
Okay, now our deployment is complete. It's good. Let's go to resources. Look at source now. Let's see. Selecting. Now let's okay. So you can choose different platform, Xamarin, Java, Node.js, and Python. Okay. Okay. Let's move it. Okay. Okay, so look at it very well. Okay. Okay. Okay, so there's a plenty functionality in this place. So I have to take our time. Okay, so you want to look at the container again. So it looks like you have any container data explorer. Yeah. Okay. Okay. I want to. All right. Okay. All right. So okay. So there's a synopsis there already. So it's a bit cumbersome, but the idea is that okay, now we have a CosmosDB account, so we can now begin to work with any other one.
Okay.
So let me look at the data part.
You have a meeting now.
I have what?
You have another meeting.
Myself?
Hmm.
No, it's our own. Yeah, I actually have another short one, like 30 minutes. This one as it's been is our own. Just trying to make sure that I'm still sharing my screen. Okay, so this slide is just showing us the process we went through.
Okay.
Okay, so there's something I want us to look at there. There's something I want us to look at there. Look at the subscription, look at the resource group, enter unique name, and then an API call. The cell is SQL. Yeah, and choose location, enable blah blah blah. So we've done this one anyway. Well, I was just trying to call your attention to I'm trying to call your attention to this. To the API call. Hello, sir. I don't know why my light is shaking. Let me just attend to it.
Okay.
Yeah, that's fine.
I'm with you.
Okay, so I was just trying to call your attention to what we did the other time. So, but remember that when we were provisioning our own, we saw 3 options. We just went with CosmosDB
Yeah.
SQL. So this was just another interface. Okay, so we start from this place tomorrow. So let's try another. Let's try our past questions.
The because I'm not sure I even checked anything out.
Don't worry, something you get. Okay. So I think we are in question 6. So let's check the next one. Okay, so for question 7, a relational database is appropriate for what scenario? A scenario that involves a high volume of what? A relational database is appropriate for what scenario? Scenario that involves a high volume of what?
Changes to relationship between entities. Changes to relationship.
I'm going to use this one.
These their answers now are very, very confusing. One has to be very, very careful.
That is why you need to now know it very well. And once you know it, you'll okay, so look at that second option. What do you think they're talking about that second option?
Geographically distributed rights. I don't understand what that means. I won't lie.
No, the moment you see this, that sentence, what do you think is related to?
Maybe locations, right in different locations or something.
What Azure services seems to carry this title? As in, I'm not saying this is the answer to this question. I'm just saying
Not
this
the answer. Not the answer.
that statement that says geographically distributed right. What services do you think can be described like that?
I don't know. Geographical distribution, are not non-relational database.
No, which one of them?
CosmosDB.
Now. Mo sì fi hàn yín bíbá yẹn sìn. Tí mo tún padà lọ síbẹ̀ gbà tí níbi tá a ka àwọn statement yẹn tá a kà. Be geographically distributed right that I told you. So, for example, if what they are asking for now is CosmosDB, now you will know it's gone through that. I'm just saying, this is not the answer to this question.
I know it's not the answer.
So now, of course, thank God, it's not even the answer. So this one is talking about a relational database. Now it's appropriate to a scenario that has, that involves a high volume.
About varying data structures. I don't know whether that's correct. That's what I will choose.
Okay, so you have gone with that one.
Yeah, that's what I'll go for. Right, I have varying data structures, so you can relate them together. Transactional right again.
Yes, your OLTP.
How so?
High volume, your online transactional processing. High volume.
Okay.
Have you forgotten? High volume. You just drop it. But it's a relational database. So they are well defined. Their data structure is defined. Their schemas are defined. They are strongly, consistent. But it's transactional. Right means that it's something that is happening. There's write, there's read. Something you can edit. So it's transactional.
Okay.
So question 8.
A visualization that shows the university's current student enrollment versus maximum capacity. Prescriptive. Prescriptive.
You might have to look at the answer again.
When it comes to visualization, it has to do with seeing something that shows enrollment versus visualization.
Okay. What do you think they are talking about when they say enrollment versus maximum capacity?
They are comparing now.
So when they now say visualization, in your head, what do you think? Is that not like a bar chart or like a graph?
Okay, cognitive. Wait. Hold on.
It's something you know.
Okay, hold on.
Take your time and process that question.
Okay.
What they are playing on your intelligence. Of course, the answers is any type of this analytics. So, sir, when they say analytics, look at this place. See analytics here. So your analytics means that it will come with any of those analytical tools that you know. So it can be a bar chart, it can be a pie chart, it can be of your graphs, your dotted, your anything. So now they are now saying a visualization. So it means that visualization means that all those tools that I can see, that I can visualize. So this visualization is now showing. What does it show? It shows a university current student enrollment. So that means you are dealing with your X and Y. Get.
Okay, is that means it's describing something for me?
Exactly. So the people that they don't understand is you get the answer. It's just simple X and Y. So your X and Y will be your normal graph now, your normal bar chart, your normal how do you call it? It's more your line to that will go up or down.
Okay, it's descriptive.
Describe me. Let's get. Question 9. The relational database must be used when
data will be stored in key and values. That's non-relational. Storage, image, video. Consistent guarantees are required. Consistent dynamic schema. It should be dynamic schema.
Yeah, talking about relational database now. The word dynamic, kilo means
I'm looking at the word schema there. That's what I'm.
that's not the only option. Always know that they want to play with your intelligence. You understand? In fact, they use that word, that schema, to even confuse you. Yes.
Okay.
Yes. Now, because it's relational database, of course, as you know, that is, it has your table, it has a schema. Abi? The moment it becomes dynamic, it kept changing. Abi, anything dynamic is not changing. Yeah. But does your relational, the value
that
you
is
want to ID?
Strong, consistent guarantees are required.
Exactly. Strong consistency. Your A is A. Your column A is column A. Your column A is say ID. The other next one is a full name. The next one is address.
But this exam is very, very confusing. Hey. The exam is designed to confuse one. Down.
You understand? So that's why we are doing this. That's why we are doing this. And once we do this, plus what I share, we will get it. So once this one is easier for us.
I'm still going to have past question I can practice myself, or this is just the one way one letting she.
Past question, Lily, we must send the video, we must send link video.
Oh, okay. At the end of this,
no, I can send it to you at any time.
No, let's finish it first, and you send it. When you finish, I have to go back and read myself before I can start answering.
So I like the way we are doing it. You understand? So that now you're getting familiar with it. So when you now go back on your own, sir?
Understanding is very, very key.
I want to like this last question, question 9 is now you have agreed that strong consistency is required. It's guaranteed.
Okay.
That's the answer. Question 10. Are you there, sir?
I'm there. I'm looking at it.
Okay.
I'm looking at column family database. I hope I don't miss this one this time around.
Well, we've not gotten to this one, so but this should be graph database. This should be graph database. Just like the way just like this number 7 explaining graphically distributed right. So when we get to graph database, so you see something that says natively support analysis of relationship between entities.
Number 7 doesn't explain graphically distributed right too. We were talking about this in question 8.
When we were deploying it, we saw it now. When we were deploying it.
Okay, maybe because we've not gotten there anyway. I still showed you here. Only multi region. Right. Look at this statement. Azure CosmosDB is fully managed, globally distributed, multimodal database service. What they use here is old. This particular interface is old. While we're deploying our own the other time, I showed you the statement exactly. The one statement here. No, but I'm deploy. When we're deploying our own, we're going to okay, CosmosDB. Okay, if I go back now, I say marketplace. If I go back to marketplace and say I want to deploy another CosmosDB. Time Cosmos. So I come here again. Okay, so look at it. And you see, sir, CosmosDB is a fully managed, fully managed, globally distributed. You understand? Horizontally scalable in storage, multi-model database. So this word multi-model too can still come out somewhere. Service backed up by comprehensive SMS. So we are looking at sir? The question.
Okay. So question 10, let's see the answer.
Analysis of relationship. This question 10 I'm talking about.
Yeah, analysis of it. No, it is this one, the Muloraba answer. Is this one? Analysis of relationship. So you can see that I chose graph.
Okay.
Well, I think DB. So question 11. Relational data uses dash to enforce relationship between different tables.
Keys.
Because the question 12. Creating closed caption text to audio files is an example of what?
Cognitive. Am I correct?
Check it out. You are correct, sir.
Okay, Mugbameji out of 6.
I thought you do it again on your own. All right, sir.
All right, no problem. See you tomorrow. I think I need to start going back to the class in my car so that first come. So I'll be getting familiar with it.
No problem, sir.
All right, take care. So Olama, you can create a little weapons.
No problem. Anytime.
Yeah.
Thank you, sir. Do have a wonderful night rest.
Yeah, you too. Bye bye.